there's going to be a series, let's see, about how many we've got 6 um, lightning talks for all of you out there. They're going to be pre-recorded, recorded and played shortly. What I would like you to do is after each one, so far as you can, so far as you can, come up with the questions, because after the pre-recorded messages or pre-recorded videos come on, the presenters will be available live to answer your questions. So once again, ask your questions while the video is rolling, and we will go over those questions with the presenters when it's finished. Please make sure that you note to whom your question, if at all possible, to whom your question is addressed. Sound okay? All right, let's get started, and I'll be introducing these. Oh, you can see it yourself that Daniel Noki is the Defense Industry and Space Unit Innovation Startup and Economics. More than a little interesting. So let's roll it.
Hi, my name is Daniel Noki from the European Commission, and I will give you in the next minutes a brief presentation on the Commission's activities in the field of on-orbit servicing and assembly, which is placed under the topic Future Space Ecosystem. But before I present on Future Space Ecosystem and the awesome activities at the Commission, please allow me to give you some words where we are with this topic amongst all the activities in the Horizon Europe program. Space research is part of Pillar 2 and Cluster 4 of this program, and is divided, as you can see here from the slide, in upstream in the EU Space Program components with its emerging initiatives, and as well as some cross-cutting activities, which are here, the bottom part of the slide, and called targeted and strategic actions. OSAM is part of the upstream space area located in foster competitiveness of space system, and the baseline for these activities in this area are formulated in the so-called Strategic Research and Innovation Agenda. The Strategic Research and Innovation Agenda is a kind of baseline document which serves as an orientation over the next couple of years in order to derive target-oriented activities supporting our community in different areas. One of these areas is so-called Future Space Ecosystem, which is mainly composed of awesome activities. And from this Strategic Research and Innovation Agenda, we derive so-called high-level roadmaps, and one of these high-level roadmaps is also available for the Future Space Ecosystem and related awesome activities. The SRIA itself and the roadmaps are, let's say, generated in very close cooperation with all stakeholders, including member states that are represented by the agencies. An important aspect which is reflected among all topics of the SRIA is innovation for space systems. For satellite telecommunications, Earth observation, and also especially for on-orbit servicing, this aspect is addressed by focusing on key technology building blocks and applications in order to foster the competitiveness of end-to-end systems, and also, of course, to stimulate the market development, and finally to allow market generation. We definitely ask all the players to learn from terrestrial sectors, to gain ideas about enabling technologies, to look at industrial process and production tools, and also design principles, and really to enhance the degree of innovation in the space domain. For on-orbit servicing especially, we see definitely in the next decade kind of paradigm shift in the direction towards highly automated, flexible, and sustainable economically viable space infrastructure. In the field of on-orbit servicing, assembly, manufacturing, industrialization, and business in space, considering sustainability and safety, key driver for our future space ecosystem. This is reflected in the high-level roadmap, which consider activities in 4 lines: disruptive line, technology maturation line, demonstration line, and a line called business framework and management actions. The roadmap activities focus on new services, including deorbiting and active debris removal, on technology and concepts for on-orbit servicing, assembly, and manufacturing, and finally on new concepts for the support of the paradigm shift towards a highly automated, flexible, and economically viable space infrastructure. Here, modularization, digitalization, standardization are key principles, together with the new concepts of robotics, automation, and AI. All activities shall, of course, serve our motivated actors to unfold their ideas and turn them into concrete solutions. Now, let's take a closer look at the activities here at the Commission related to on-orbit servicing, assembly, and manufacturing. What we did in the last 5 to 6 years was to concentrate our activities on the key technology building blocks and applications for on-orbit servicing. We implemented those activities in the context of our strategic research cluster Space Robotic Technologies with the support of the Per-Aspera consortium that you might know already. What is still ongoing from these activities is basically our 2 mission studies, which are in phase A and B1. These mission studies should ultimately, of course, lead to an orbital demonstration mission, which we hopefully will conduct in Horizon Europe. So what we plan now for Horizon Europe, in the work program 21 and 22, is to subsequently to continue our support for the OSAM community, and therefore we programmed 4 activities mainly. As you can see here, we would like to work on new scalable satellite platform concepts and building blocks, which should increase the degree of satellite modularization in order to foster a more efficient servicing. We would also like to work on new on-orbit servicing concept in general, so we allow to explore new ways of conducting and implementing your business, as well as we have an important activity on the development and the implementation of Industry 4.0 means, and of course also of AI for space. Here we definitely would like to profit from knowledge the space domain should gather from terrestrial domains. And finally, we have an activity, continuation basically from the mission study, which ends up to mission phase C, so the detailed design for the orbital demonstration mission. In parallel, of course, the Commission also works on a framework, so-called business framework here, the European Operations Framework, which is developed and implemented by Per-Aspera. And of course, the Commission has also activities in the context of space traffic management. So at the end of my presentation, I would like to come back to the 2 mission studies that I have mentioned before and spend on each of the study a word. So the first mission study is led by Thales Alenia Space with a consortium composed of DLR, so the German Aerospace Center, GMB, PIAP Space, and SINTEF. This mission study, or this concept, focus on a free flyer system, so a servicer with a manipulator on the platform, and which is basically able to maintain, repair, and upgrade, and also refuel multiple clients. The second mission study is called Period. Period is focusing on the assembly and manufacturing application. The objective here is to build a satellite in an orbital factory from a satellite kit with the support of robotic systems. The consortium is composed of Airbus, GMV, CNR, DFKI, Space Application Services, EAS and Technology Innovation Services, and Innovative Solutions in Space. The consortium lead has Airbus. With these slides and this small contribution, I would like to thank for your attention and looking forward to the discussion. Thank you.
Okay, great. Thank you. A couple of notes before we go to the next speaker. Please keep the questions coming. We've got a bunch of them. And note that these are pre-recorded presentations, so we've got limited control over how they appear, what the sound's like, and so on. And also, we will not be asking questions of them until the end, but we will have these folks live at the close of this series of presentations. Please use the Q&A button on the screen for your questions. We're not monitoring the chat function for your questions. But so far they look like good ones, so please keep it up. We have Florian Rems up next. Read his role and responsibility there. It's interesting. The Ricardo's Plus project is for development of key technologies. This is more than a little interesting. Inspection, rendezvous, capture, and tumbling, which are developed in a holistic, which I presume means, well, I know what holistic means. They are all integrated together alongside the ground segment and mission operations procedure. So this could be quite an interesting, quite a productive, and probably quite useful capability. So let's get started with Florian's presentation.
Yeah, thank you for the opportunity to present at the Global Satellite Servicing Forum this year. I would like to give you a quick overview of a project that deals with on-orbit servicing that we have at the German Aerospace Center. The idea behind this Ricardo's project, Rendezvous Inspection, Capture, and Detumbling by Orbital Servicing, is that an on-orbit servicing mission, especially if you look at the more complex scenarios with an uncooperative target and client and robotic manipulation of it, is very complex, and many systems have to work together autonomously and fluently, despite having larger uncertainties and so forth. We decided to approach this in a holistic manner. This means the development of inspection, rendezvous, grasping, and detumbling, and of course also of ground operations, the ground systems and the operational procedures together in a unified interdisciplinary way. And we consistently verify this on a fully integrated end-to-end simulation environment that includes hardware-in-the-loop facilities, like I will show you next slide. And also, of course, real sensors like a rendezvous camera or a robotic manipulator, and the real GSOC flight operations systems and multi-mission control rooms. So we're doing we're flying these mission simulations as part of the development process, just as other missions are flown at GSOC. And our intention is clearly to have a technology demonstration mission in orbit, maybe together with a partner. Maybe at this point it's a bit abstract, so let me give you an overview of the architecture of the whole system. I think then it will be much clearer. So we start with a piece of simulation environment, the space segment, which is actually supposed to lead to flight software and hardware. Then another piece of simulation environment, and finally the ground segment. In the middle now, at the bottom, we start with a dynamic simulator, which takes care of orbital and attitude dynamics of chaser and target. And we continue with a simulator of the satellite bus, which realizes the basic functions of a typical satellite, like data handling, things like that. Then we go into simulation of the communications link, like delay, jitter, and other effects that you have in a real communications link to a satellite. Then we go into the flight operation system, the network infrastructure, and finally we have a pretty standard satellite bus console in a multi-mission GSOC control room. This is kind of the spine of our setup. Now, starting with rendezvous. We have our EPOS, European Proximity Operations Simulator, connected to the dynamic simulator. And EPOS realizes the approach, the rendezvous, with two robots that mimic the movement of servicer and client. And I will show you an image in the next slide. Then we have the rendezvous GNC system, which is mainly software and a couple of rendezvous sensors like cameras mounted onto EPOS. Also there is mounted an inspection system, a stereo camera system. And then on the ground side, we have the rendezvous console, which of course allows to monitor and control the rendezvous GNC system. The inspection system is controlled by the satellite bus console. Then quite similarly, on the other side, we have the OS sim facility in the Robotics and Mechatronics Institute, which is kind of similar to EPOS but smaller and specialized for the grasping, for contact dynamics. On this facility mounted is our robotic grasping system, the form of a lightweight robotic arm. And of course, on ground, we have a robotics console. This is a bit special. We also have there two modes of operation. One is visual servicing, which is quite autonomous. So the grasping is made based on machine vision. And the other mode of operation is telepresence, where with this haptic device, the robotic arm in space can actually be controlled in real time. We are a real-time link. If you look at, let me just use the laser pointer here. If you look at, for example, the OS sim, of course, the robotic grasping system is mounted on the OS sim. So if, according to the dynamic simulation, we have a change in relative position, this has consequences, for example, for the camera mounted on the manipulator. In the same way, if EPOS moves, the rendezvous cameras see different things. So if we now proceed here, we see that these are closed loops, closed real-time loops. Yeah, the facilities move. We see something else in the cameras. We create forces and torque, of course. The dynamics reacts accordingly, and the robots move again. So these are two real-time closed loops that we have here, and we do this simultaneously. So this is really correct. Both hardware-in-the-loop simulators get their data from the dynamic simulator at the same time. And we do the simulations also at the same time. So as soon as the grasping is due, the OS sim takes over, but both facilities are commanded at the same time. Okay, I hope you have now a better impression. And well, let's look into some benefits and possibilities. So what we do here is that we use an agile approach, which means that every 2 weeks we use the setup to test and verify the recent changes. So we have like increments that we do step by step, and we can almost immediately test these in tandem with operations also, yeah, in tandem with all systems, which also is sometimes called compatibility before completion. So we see problems very early, not at the end of a project, but very early. And we have the possibility, of course, with the setup to go from a laboratory level to an engineering model level directly to the flight model level concerning software and also hardware. We can, for example, integrate an embedded system like an onboard computer, even the flight model, and have like a continuous development approach here. We can even verify the ground operational procedures at just before launch. So in principle, we can do test campaigns on the EPOS facility for customers also specifically. So this here, EPOS facility. We can also provide the whole setup for test campaigns. And of course, we're always interested in cooperations. As I have emphasized, we are really working also on the flight systems and see this as a holistic concept. Okay, then my last slide. We also have a nice YouTube video, so if you want to know more about this project, it was formerly called On-Orbit Servicing End-to-End Simulation Project, so don't be confused. Please just search for it on YouTube, DLR On-Orbit Servicing. You should find it, and there you get a really good impression what we do and how this all looks like during a simulation. So thank you for your attention.
Great. Thank you, Florian. Although, Florian, there is a Florian on the panel live in just a bit. The Florian who just spoke will not be there, but still it's worthwhile thanking him. All right, a couple of things. Please keep the questions coming. They're really useful. I'd like you all to check out the chat. Mark sent out a note to all of us that if you are interested in continuing the Q&A and discussion about the on-orbit servicing capabilities of the German Airspace Center, DLR, please send an email to his email address, and he'll invite you to a WebEx meeting following today's Converse session. So please take a look at it. And I hope all of you, all of the participants, regularly check the chat. There's a lot of interesting messages going on back and forth, so please do. Now we have Maurizio will be speaking about, well, he works with OneWeb, and he's going to be sharing perspectives on on-orbit servicing in the LEO context. So pretty specific. Okay, roll the video.
OneWeb is a global telecommunication operator that is deploying a constellation of 600 plus satellites in LEO polar orbits at 1,200 kilometers. We have executed 10 launches to date, which takes the number of satellites in orbit to 322, meaning we have deployed more than 50% of our constellation. By the end of this year, we'll provide continuous, fast, reliable, low-latency broadband connectivity anywhere in the world at latitudes higher than 50 degrees north. OneWeb's vision has always been to connect the unconnected, bridging the digital divide and doing it responsibly. The use of technology to drive solutions to social and environmental challenges has expanded to space, up to the point the proper functioning of economies and society fundamentally rely on space-based services for which there is often no alternative. Think at Earth observation satellites, broadband communication, maritime communication, position navigation and timing. The increased interest in space and pace of launches in recent years has highlighted the need for action to deal with space debris and collision avoidance in order to ensure space remains sustainable, safe and accessible for all. Hence, for satellites and space systems to function properly, access and use of the orbital environment needs to be safe and sustainable. At OneWeb, we believe good stewardship is good business. Responsible space gives us a framework for guidelines and principles that prioritize sustainability in space through environmentally friendly practices and organizational behaviors across all areas of our business. So what is responsible space? We use the term responsible space to describe a far-reaching framework of principles and best practice on which the company and other space industry participants can build a shared commitment to sustainability in space. The fundamental premise is that space is a shared natural resource, which, if used responsibly, can help transform the way we live, work and interact. Responsible space also builds on and strengthens work already being done with the broader space community to address this important issue. At OneWeb, we apply the principles and values of responsible space into all areas of the business. Firstly, as we build and operate satellites, we apply responsible space to design and operational practices, technology innovation and collaborative partnerships. In terms of employing responsible space design and operational practices, we have a rigorous satellite qualification and testing program to assure quality and reliability is achieved prior to launch. Our launch and operational orbits were selected to avoid the most populated regions of LEO. Our fault-tolerant constellation configuration virtually eliminates the possibility of intra-constellation collisions, even under high failure rate scenarios. In terms of responsible operations, we maintain precise satellite position knowledge from launch to re-entry. Our satellite propulsion systems and global telemetry and telecommand provide agile maneuvering capabilities. We coordinate with the 18 SPCS in the US and other operators to manage conjunctions with other objects. Separating operational planes by a small amount of altitude virtually eliminates the possibility of intra-constellation collisions, even between failed satellites. An automated GPS-based orbit determination processes maintain high accuracy trajectory solutions and high efficiency electric thrusters, which, coupled with OneWeb's global connectivity, provide a high degree of maneuvering agility from launch to controlled re-entry. In terms of responsible disposal, our high satellite reliability requirement is levied on its ability to deorbit. We will deorbit our satellites within 5 years of decommissioning, and our satellites can be completely passivated. Our satellites are also designed for demise, such that little to no debris survives atmospheric re-entry to reach the ground. We have outfitted every satellite with a grappling fixture or a magnetic plate to facilitate rendezvous and capture, if such a need were to materialize. So why does responsible space matter? OneWeb recognizes the emerging space industry as a tremendous opportunity to develop communications and create new pathways for economic development, global education, rural healthcare, and advancement in environmental science, in a world where 40% of our global population has no access to the internet. We believe space-based communications can improve efficiencies and help solve many of today's pressing problems. As first movers, OneWeb is in a unique position to lead by example. OneWeb also believes industry and governments have an exciting shared opportunity to facilitate the development of new technologies, jobs and industries, as well as increasing investment, diversity and inclusion in local communities. Responsible space speaks for the development of a sustainable, innovative and vibrant ecosystem, and for the benefit of all co-participants in this new era of low Earth orbit constellations. So what is OneWeb doing in advance to responsible space? In June 2019, OneWeb reaffirmed its commitments to responsible space, building on and strengthening work already begun through its Sunrise program, the public-private partnership with the European Space Agency, and in collaboration with a wide range of partners preparing solutions for the active retrieval and removal of debris from space. With OneWeb, these partners are focused on cutting-edge technologies needed to address future environmental remediation needs. OneWeb is also participating in the development of a space sustainability rating system, an effort proposed and led by the World Economic Forum that will reward responsible operators for the good space environmental stewardship practices. Other OneWeb commitments include the adoption of practices that support job creation, investment into local communities, great diversity and inclusion. Who are OneWeb's partners in the responsible space community then? OneWeb is not alone in advocacy for space environmental stewardship. We're working with the research partners, governments and other LEO constellation operators to support and develop best space situational awareness and space traffic management capabilities. It is imperative that we develop a consolidated and comprehensive regulatory framework for space safety and orbital debris management, and that this framework is coordinated with international counterparts everywhere for it to have full effect. Secondly, in terms of developing the space ecosystem, the space industry has a shared responsibility to develop technologies and adopt practices that support environmental stewardship, sustainable job creation, investment in local communities, diversity and inclusion, as we said. OneWeb is collaborating with a range of partners preparing solutions for actively retrieving and removing space debris from space. We're working with industry to develop and standardize an advanced in-orbit capture interface. As mentioned earlier, we're working with the 18th SPCS in the US and commercial companies to advance the state-of-the-art in space situational awareness. We employ ethical practices in supply chain procurement, and we support advancement of communications network security. All Earth orbit objects are given a standard mathematical formula called two-line element. OneWeb is sharing our TLEs, as they're called, to enable the astronomy community to map our constellation locations precisely and schedule sensitive observational campaigns to avoid our passes. Last but not least, it is of paramount importance to support the policy outcomes through collaboration. The space industry has a shared responsibility to work with governments to advance causes that can have transformational impacts and solve some of the world's most challenging problems. Our mantra is leave no trace in space. Responsible space is a term that encompasses and describes practices that drive sustainability within the space industry. This avoids harming our LEO environment whilst developing this new frontier in mobility, communications and connectivity so that it works for and benefits generations to come. Net zero space, where space debris is analogous to carbon emissions and climate change, should be our ultimate goal. Space is a global shared natural resource. It is up to all of us to protect it. Thank you.
Great. Maurizio, thank you so much. Kind of a bummer that the volume was so low, but you'll note that, that in the chat section, Ian pointed out that they're going to try to get a recording posted to increase the volume. So yeah, note to self. Also, for the questions that you guys have been asking, which are good ones, they're terrific, they keep coming in. Please note to whom the question is addressed. There are a couple in there there are a couple of questions in there that I'd very much like to ask, but I would very much like to ask it to the right person. So please indicate to whom you want the question addressed. So Carl Stolleis is going to be speaking, and he has a complete description of complete professional biography there, and you can read it for yourself. This should be, well, they all are, but this one should be terrifically interesting. Okay, so let Carl's video roll.
Morning, everybody. My name is Carl Stolleis, and I work for the Air Force Research Lab Space Vehicles Directorate. And I wanted to say thanks for the folks for allowing me to talk today about commercial refueling opportunities. I do want to drop a disclaimer to start with, which is the views that I'm about to present are not the views of the United States Space Force or the Air Force Research Lab. They are my personal views on how things are going and where things are headed. So let's jump right in. So I don't think you can talk about commercial refueling until you talk about the current architecture versus where we're going. So where we are right now is we have a bunch of clients, potential clients that are up there that have that were not designed to be refueled. And there are some missions up there like RSGS and NASA's OSAM-1 that are specifically designed to refuel unprepared clients. The costs of those missions are being driven in large part by the fact that these clients are not capable of being refueled and weren't designed with that in mind. Refueling is not a new idea. It's something that's been around for a while, and a lot of people would say that the technologies involved are not only not necessarily new, but we could have done this a long time ago if there was a commercial ROI on it. And I tend to agree with that. So the future state, where would we like to go? Well, we'd like to end up with what a lot of people would call the hybrid architecture. Now, I'll tell you, my view of the hybrid architecture is one where we still have traditional, for lack of a better term, HVA clients, or as I like to call them, school buses, drifting around in LEO and GEO. Those numbers are going to get fewer and fewer, I think, in LEO over time. And that is a result of the proliferated LEO architecture that you're seeing right now. There will always be a place for these large clients in GEO. There are just certain missions that the mission parameters drive the size of the vehicle. And there is a place for them in the world, but I think you'll see the same proliferated movement in GEO, or that's happening in LEO right now, moving into GEO. So as that happens, the hybrid is that mix of smaller proliferated systems and larger systems. And then as we push out into cislunar space, we have the additional problem of, well, you can't do all of the missions out there with billion-dollar HVAs. We're going to have to figure out how to get smaller spacecraft out there. Their spacecraft are going to be smarter, but they're also going to have to stay out there longer because the launch costs are not coming down the way we'd like. Things that move into cislunar are going to be really expensive. And we should work as hard as we can to keep those things out there. So where does this all go? The general assumptions that I have made all along is that refueling in LEO only makes sense under a limited circumstance. And that is, right now, we launch GEO satellites and lunar satellites into those orbits. But there is an opportunity to start making those satellites smaller by decreasing the beginning of life fuel load that they have on them and launching them into LEO and taking advantage of smaller rockets, more responsive launch, cheaper launch, and then either refueling them in LEO so that they can raise their own orbit out to GEO or wherever they need to go, or we can use refuelable tugs to move them out into their final orbit. So that is a unique case, but do I think that proliferated LEO constellations will be refuelable? No. The economics, at least as I understand it, don't make sense. It's cheaper to just build a new satellite and launch one, dispose of the old one, than it is to actually try to refuel. As you start getting into GEO, that's where things, they start getting interesting. Like I said, there is the case where we start launching smaller vehicles because a lot of the size of the vehicles is not just driven by the mission parameters, but it's also driven by the amount of fuel that's required for that satellite to live its entire life. If we can launch smaller vehicles, say with a 2 or 3 year fuel load, and we can get a revisit rate that's half of that, then those satellites can be refueled on orbit and their life can be extended, but not in the sense that we normally think of them. It would be extended 2 to 3 years at a time through its 15 or 20 year design life. And there is also potential that a satellite wouldn't have to hold back some substantial fraction of its fuel mass to account for disposal costs. So it could actually use all of its fuel and it could still be disposed of correctly by going through a refueling operation. So that's where really GEO kind of comes into play. Cislunar, like I said, that is an interesting case because I think the break point is somewhere between GEO and L1. As you move into L1, there is not only the case for keeping them up there. Number two, from a debris standpoint, we don't really have a viable disposal orbit like we do in GEO. In the 3-body space right now, everybody's planning on crashing end of life into the moon, and I hope everybody in the audience thinks that's a terrible idea. The moon should not be our universal garbage dump. So trying to figure out how to make assets that are in cislunar space not only refuelable but sustainable even beyond refueling. I think NASA's already looking at this at Gateway. There is an opportunity to start removing fuel in the form of liquid hydrogen, liquid oxygen, or water off the surface of the moon. And we'll come back to that in a second. But the case starts getting made for refueling. Okay, so now I'm supposed to be talking about commercial refueling. I think what you'll see is the same thing that has happened in traditional space, quote unquote, traditional space. LEO is already arguably fairly well commercialized. So if there are refueling opportunities to be had for satellites, I think they will occur in LEO first. I also think that there is a substantial fraction of the satellites in GEO. If you look, I think commercial satellites make up something like 80 to 85% of the actual satellites in GEO. As commercial operators start to shift towards this hybrid architecture, and I assume they will, there will start to be commercial fueling opportunities and the ability to make money and increase ROI in GEO. Then, assuming that we're right and we move into the lunar environment the way we think we're going to, there could be opportunities out there, but I think those are pretty long term. The question becomes then fuel types. So in LEO and GEO, typically we fly hydrazine and xenon. There are some of the green, especially multi-mode propellants that are coming on. And one of the problems that we have with this notional refueling architecture and that commercial, government, everybody is going to have is, what is the fuel type? Because if we have this complex system with 10 to 12 different fuels, we're in trouble. That's going to mean a logistics chain that's incredibly complicated. It's going to reduce the ROI and it's going to limit the number of commercial opportunities. Now, why is that interesting? Well, so number one, I think in LEO and GEO, we need to start getting down to a single fuel type. What I call the JP8 of space. Where it gets interesting is there's a lot of people who have looked at the idea of refueling in LEO and GEO and using water and peroxide and other things that are based on hydrogen and oxygen. Right now, I'm not sure that those are going to be viable, but those are going to be viable if you move out to the moon because that's the fuel type that's going to be available there. Now, whether getting fuel from the moon back down into GEO is ever going to make sense, I'm not sure. I'm not smart enough to understand if that is where the world is headed. But what I see is in all of this, I see the natural progression that's already starting to happen. People moving into LEO, the idea of tugs and refueling and breaking the paradigm of satellite design will enable commercial opportunities in LEO. But I think those LEO opportunities are going to be limited, and God knows I could be wrong. I think the real strength comes in the GEO market because that is where that tipping point. And what's interesting is in GEO, we will start building the skill set that we need to actually go out in the cislunar environment now to L1 and L2 and do those things. So it's an interesting problem. It's complicated. I think the time has come between technology, computer, software, onboard computing, and the push to sustainable architectures that has made this the right environment to go out and do these things. So we're counting on you guys out there in the commercial world to figure this out, and my job is to help you figure it out. So good luck, and if you have any questions, please let me know. Thanks.
Great. Carl, thank you so much. Let's see, once again, a reminder to the audience, please put your questions into the Q&A via the Q&A button on your screen. And once again, please identify to which among our speakers your question is addressed. That would be great. And there's lots of comments about the low volume of some of our speakers, and it's my Macs all have digital VU meters available, and I suggest that folks who are not using a microphone or using their Mac or other laptop microphones call up the VU meter, make sure they're getting nice strong signals or sending out a nice strong signal. Okay, William Carter, the program manager, Defense Sciences Office at DARPA, is speaking next. So William, Bill, you're up.
My name is Bill Carter. I'm a program manager in the Defense Sciences Office here at DARPA. And I want to share a little bit about our program regarding in-space manufacturing called NOMAD. NOMAD, spelled NOM4D, stands for a little bit of a mouthful. That's Novel Orbital Moon Manufacturing Materials and Mass Efficient Design. The purpose of the program is to determine the range of possibilities associated with manufacturing in space, whether we derive material from Earth using highly efficient engineered feedstock created here on Earth and launched and then manufactured into large structures on orbit, or perhaps material that is derived from the moon. And in both cases, we are trying to transcend the limitations of today's technology. Today, we develop a structure on Earth. We spend nearly a decade doing validation and making sure that that structure, when it gets up onto orbit, can deploy into a large, efficient, and stable structure. We'd like to invert that paradigm. We'd like to be able to launch pre-manufactured feedstock or derive material from the moon and create those structures on orbit, perhaps using robotics and manufacturing techniques that we will develop under this program. The kinds of goals that we're after include being able to put very large structures on orbit. These could include, for instance, very large solar arrays to allow us to have megawatt-class power plants on orbit. Could include very large antennas that allow us to not only investigate the cosmos, but also understand the cislunar environment, or perhaps understand the Earth. And finally, large, scalable optical systems that would have the precision to be able to measure very faint objects or have very high resolution. Those goals are shared across these domains, whether we derive feedstock from the Earth or from the moon. We're also in this program looking to understand and push the bounds of design. Today, the paradigm is that we launch a structure and we make sure that it is extremely stiff, in the sense that any perturbation to that structure will not change its shape or cause it to lose performance. We typically think about that today as a lowest minimum resonant frequency of the structure. And we make sure that that resonant frequency is above any of the frequencies associated with those perturbations. I'd like to see if we can explore the space below that paradigm and be able to use mass much more efficiently, still have stable structures on orbit, but be perhaps 10 times or 100 times less stiff than what we use today. Now, if we're successful, we should allow the DoD to utilize mass much more efficiently than we do today, and be able to launch in a single fairing. Even though those are getting bigger and less expensive, we still would like to use them more efficiently. So in that single fairing, be able to launch these large structures and make them work on orbit. Okay, so that's an overview of the NOMAD program, and we'll be interested in taking your questions and understanding your perspectives. Thanks very much.
Hello, this is Ian Christensen. Harley, are you still connected? Okay, I think we may have had a brief internet issue with our moderator. So at this time, I'd like to introduce Debbie Tomek, who is the Senior Advisor for On-Orbit Servicing, Assembly, and Manufacturing at NASA, to give some remarks. Good afternoon, Debbie.
Hi, good afternoon. Having some technical difficulties on my end too. Can you all hear me okay? See me?
You're coming through clear, thank you.
Okay, great. All right, well, thanks for having me today. What I'm going to talk about today, I'm going to take it up to a little bit of a higher level. First off, I want to thank you all for letting me participate in this. And the content this morning has been really rich. So I really want to dive into a lot more of what folks have shared. They've just touched on a lot of things. But what I'm going to touch on here just the next few minutes right before our Q&A is talking about what we've been doing within the government side, developing and working towards coordination of OSAM community. You heard our Deputy Administrator, Pam, talking about collaborate to compete, and collaboration really starts with the government and us figuring out that which we need and our requirements going forward. We've been working on that for the past handful of months. I've been working mainly with our partners in the Space Force and also NRO. For those, the quick pedigree behind that is we've got a Science and Technology Partnership Forum that has existed between our three space agencies. And again, that's the core of space agencies at this point that has worked on these different topics. OSAM was one of them a few years ago. So this coordination effort, this initiative we're working is born or graduated out of that S&T Partnership Forum. So these handful of months, we've been looking at how we can develop a joint vision and strategy across our agencies as a starting point. And then we move into engaging industry and academia and the broader partners on this going forward. So we've been really looking at how we can, what a joint vision and strategy looks like, some of the products we've been developing in getting to a point that we can start folding everybody in for a roadmap. We've developed at this point a OSAM state of play, which is really where everything is today collectively within the government. And again, we've got to fold in that industry piece coming soon. We've also looking at what we call an OSAM ecosystem. So if you want to think of the OSAM state of play and the OSAM ecosystem as really being the two ends of the roadmap, the ecosystem being that which the use cases, those things and those requirements across our agencies that are important to us. Very unique mission objectives between NASA, between Space Force, and between NRO in that essence. So we have managed to find a nexus and a really good Goldilocks zone between those capabilities that really meet each of our unique mission and objectives. And I'm pretty proud of what our interagency team has accomplished in that aspect. Getting the federal involvement on this on a broader scale has also been a huge push on our part. Can we get take this up to a level where it is not a Space Force, not an NRO, not a NASA thing? We've been wanting to get away from this looking like this is our own hobby horse. That's not the case at all. So glad to see we're getting a lot of good traction at the federal level with OSTP and the Space Council. I know a lot of you are the same thing. Again, this community, there's so much momentum behind it. And that collaboration is key to us really advancing these technologies. Looking at all these amazing things that our industry partners are doing, it's incredibly exciting. Figuring out how we can harness that, how we can send the right demand signal as a government, right? And then a lot of that means us kind of government getting our affairs in order and figuring out what those different models are, how it is that we can leverage you to not only meet our requirements, but to spur the space economy going forward. But what we've also found, and again, this is a subject of this conference, and I hear it a lot when we talk about OSAM capabilities. I know we all know OSAM isn't the only thing. It isn't the only mission, but it is. We look at it as a foundational cornerstone capability to the development of space infrastructure holistically. And for that, we need other things to advance at the same time: PNT, space comm. But OSAM as a catalyst for space infrastructure. So us looking at those different mission concepts that again leverage how it is that we can meet the needs of the government for starters, right? A civil defense, intelligence community, how we can share. It's the beauty of OSAM capabilities is how cross-cutting they are. And for us, we've developed concepts. I know everybody has heard the space superhighway terms. My colleagues have used it tons. It's not anything we invented. But we're starting to look at and putting meat on the bones of what those building blocks need to look like for space infrastructure, how we move that forward, what are regional hubs at strategically placed orbits for us that can meet the needs of all of our different requirements in the government, as well as spur the economy in the private sector. Those are all the things we're talking about today. It's the logistics, the space domain awareness, it's the refueling, the repair, the servicing, the upgrade. It's all of those elements that we are all going to need out in space, because we are all seeing the same growth at the same time. And how do we manage that? And those are a lot of the bigger questions we've got to not only spur this development, this growth from the government side, but we also need to figure out what is the right model. So we've been looking at consortium models for a while. We've got really good models that have been successful here. The LSII, Lunar Surface Innovation Initiative, that's leveraged our Lunar Surface Innovation Consortium. So there's different models we're looking at on how best to leverage that. But what this all drills down to, and a key piece on this, is the standards development. As we move through time here and all these technologies continue to advance, space infrastructure develops into this ecosystem that we all envision it to be. As Pam had said, it's so important that we collaborate together on this and we advance this together. And this is really across not just us figuring out our piece on the government side, but folding in the industry partners, folding in the Converse, all the standards development, and looking at, again, what are the different models to advance at. We've got a lot of work to do, whether it's on-orbit activities, regulations. We've got a lot of runway ahead of us, but it's an exciting time, and I look forward to more collaborations in this area. We have seen a lot of growth this past year, so we're pretty thrilled with that. So we want to keep that momentum going, because I know most of you out there probably share the same vision as myself and many others, that we see how transformational on OSAM capabilities can be to space architecture. I joke around all the time that all of us have, our brains are the shape of payload fairing sizes, and it's hard for us to break out of that paradigm on what we would actually develop up there if we can shatter the tyranny of the fairing. So that's exciting to think about, that vision and what that could be. But what goes hand in hand with that is all of these pieces around standards, how we all work and interface together up there. And that's why it's key. We need your help and industry's help to do this, so the government can leverage that from you all. So I look forward to more discussions, and thank you again for letting me have time here to talk to you all.
Right. Thank you, Debbie. And thank you for, was that Ian who stepped in for me just before Debbie spoke? My apologies. I wasn't having internet problems. One of our big cats came into my room and here, my office here, and coughed up a hairball, which apologies for sharing, but that was, I did not want that to dominate what was, to overwhelm what was going on with the presentation. So, okay, so folks, continue to ask questions. A couple of things. I will be reading from the questions. I'll be reading from the questions, thanks, and asking a few of my own. Also, it is entirely appropriate for the members of the panel members to ask other panel members questions. I think you guys have, speakers have access to the Q&A feature, so feel free to ask questions that way. I'm going to begin. I'm going to ask a question that I'm going to ask Debbie a question that I think I'm going to ask a couple of others. Nice presentation, Debbie, nice laid out plan and so on and so forth. What keeps you awake at night?
What keeps me awake
on this topic?
Yeah, what keeps me awake at night? That's probably a pretty easy answer. It's watching how other capabilities are developing quite quickly in red countries. And I look at how we've got that mix between, we need to collaborate with our international partners, right? That is key here, right? We've got to, all of us are going to be up there. The capabilities, the technologies we've got to overcome and develop mean we've got to involve everyone. But I think from this standpoint, us making sure that we learn how to properly use space and that we develop these techniques so that we can demonstrate responsible behavior in space. And that, falls under the standards aspect, right? How it is that we can, and I think we've got an opportunity here in this community to move forward with different ideas on how we can demonstrate responsible behaviors in space. And I think we've got a lot of work to do there. The other thing too, collaboration is hard. And it's, advancing these technologies. Again, I love that we all just share the common vision around and the passion about wanting to advance these. There's many different models and ideas and things floating out there, right? Different, factions working this and working this, but us really learning to kind of find that common ground and work together, independent of different missions and goals and objectives. For me, getting these technologies to TRL 6 or 7, that's where we want to go with so much of this and transform space infrastructure. We can all go off and use them for our own particular use cases. But to me, I'm pretty passionate about us figuring out a way for us all to work together.
So if I may say, what keeps you, that was a long list of what's keeping you up at night.
There's a lot. I don't sleep much. Harley.
But it sounds like at the 100,000 foot level, it is international collaboration and integration between the commercial interests and NASA's interests, so on and so forth. It's integrating with creating, it's an overused word, creating an ecosystem of space servicing, assembly, manufacturing, and so on.
Right, and doing that responsibly. We're going to have commercial sector up there. We're going to have many different governments, and we all have to, much like we terrestrial, we have to figure out how we all interface and work together. We've got a lot of runway there to figure that out in space. And I look forward, again, I think for and I'm speaking just for my country and for NASA, we've got an opportunity to work with partners to demonstrate those responsible behaviors in space so that we can all grow it to be the ecosystem that we envision.
Good. Yeah. Thank you. Let me. I'm going to ask the same question of Florian, with your own perspective, but also more of a European perspective. Same question that I just asked Debbie. What do you all and your colleagues, for example, what keeps you guys up at night? What worries you?
Well, good question. So the talk you have seen by my colleague Florian just showed that we have developed a lot of technologies which are used for on-orbit servicing. And the reason for that was we have been participating 2 missions, so-called DEOS mission, which had the goal to capture a tunneling satellite in low Earth orbit, and the OLIVE mission, which was designed for orbital life extension, which is now more or less the same business case MEV, Mission Extension Vehicle, has. And congratulations to Northrop Grumman for that. However, we developed a lot of technologies, but in Germany, we had not been able so far to perform these missions. So we have developed not only a test facility like EPOS, the European Proximity Operations Simulator, and which you have seen by my talk, but also we have developed a capturing tool for geostationary satellites, which is able to capture the Apache's engine. We have developed a robotic arm. You will listen to a talk tomorrow, the CESA arm, our institute. But we are still trying to participate in a mission. So that's kind of a problem. And that goes back to the 80s. In the late 80s, we launched a satellite at our Spacecraft Operations Center in Oberpfaffenhofen in Germany, which was defect, which had problems to bring out the main payload. And this triggered the development of on-orbit servicing technologies. So we have been now for many, many years at the German Space Operations Center and the DLR, the German Aerospace Center, been working out technologies, but not, well, we have tested some of the technologies in some test missions, but we didn't participate a real mission. But maybe together with the European Commission, so that was the talk of Daniel Nölke, or ESA missions, we will finally be able to participate in a real mission. Yeah.
Okay. So once again, to oversimplify what you just said, apologies for this. So technology development, continuing to design and build what is necessary, and then also a use case, one or more satellites that you could put the servicer to use, or refueler, assembly, whatever you could put it to good use. A fair simplification?
Yes. Yep.
Good. Great. Thank you, Debbie. Thank you, Florian. So let's go around. Here is a question that is, I like this one. It's for, hold on. I think it was removed from the list. All right. Debbie's. Here's a real top level one, but it may be the answer to the question may be something that's in the back of folks' minds. So apologies if seems over trivial, but perhaps not. We'll start with for Carl. Say, listen, what is the fuel in the satellites typically used for, Carl?
Well, let's see. As I understand it, let's talk about geosatellites, because I mean, if you think about it, the size of those spacecraft are being driven by the size of the beginning of life fuel load. So pre-positioning, either post-launch, final orbit insertion, and then a significant fraction of their fuel is held back for disposal at end of life. If it's just a geosat and all it's doing is maintaining its position in its slot, fuel usage for that is pretty low. So that's why I think that as we start talking about OSAM as a possibility, we can break that paradigm of, okay, I don't have to hold back 15% of my fuel load for disposal, right? I don't have to put 50% of my fuel load just to get into my final orbit. So, but actual maintenance, as I understand it, is fairly small in terms of actual fuels.
All right. So thank you, Carl. I've got a question. Somebody asked it from the audience and then it disappeared from my list of questions, but I thought it was a good one. So I hope that I'm fair to the.
Hey, Harley, check the answered. I typed out answered, and there's a little answered tab in there. That's why they keep disappearing.
Oh, sure enough. Carl, I thought his question was a good one. So let me see if and he or she asked you or Maurizio. So let's see, correct me if I get this one wrong, as from memory. He said that with the decreasing, when we hope it continues, the decreasing cost of launch vehicles, is it really going to, in your view, is going to really continue to be useful to develop the capabilities for in-space servicing, repairing, upgrading, and so on, refueling, if you can more inexpensively launch another one? So Maurizio first, and Carl, was that anything like your answer?
Thank you. Thank you, Harley. I think the perspective is different if you are a GEO operator or a LEO operator, right? That's for sure. Regarding LEO operators, the concept of refueling or in-orbit servicing for life extension, I don't see these as having a lot of traction, especially if you look at LEO constellations are designed for an operational lifetime that is lower compared to the operational lifetime of larger geostationary satellites. So the approach is not looking at one single large satellite, but a fleet, a constellation, which is large, very large, but you're talking about a system level approach. So it's really changing the perspective of looking at a satellite of a fleet of one or few geostationary satellites compared to a fleet of hundreds of satellites. Then there's a second point which is related to the evolution of technology. So if you had the opportunity to continue buying, your phone, and then all of a sudden, it becomes, 7, 8, 10 years old, I think would be much more interesting and powerful to take advantage and leverage from the evolution of technology and launching more capable satellites, more capable payloads in orbit. So in that regard, in-orbit servicing for life extension for LEO constellation, I think has limited utility. regarding in-orbit servicing for emergency disposal missions, absolutely 150% supported for that.
Okay. Carl, would you like to add, in answer to that particular question, would you like to add anything?
Yeah, I think that was a perfectly strong answer, and I'll get on my three body space debris soapbox here. And I think it's what I typed in the answer is we have a LEO debris problem already. The reason that disposable satellites in LEO make sense, though, is you have a easy disposal method, especially if they're smaller. GEO, we do have a disposal orbit. There is some question about how stable that orbit is and some of the things that we put in it. We could definitely start causing problems. There is no such thing as a stable disposal orbit in three body space. So as we move further out, if nothing else, just being able to sustain those assets is imperative just from a responsibility perspective. What do we do with all this stuff that we're putting up there? And then, you asked Debbie, what keeps her up at night? What keeps me up at night is the cost of all this stuff. The cost of launching new material. I don't think it's linear as you move out. I think it's exponential. So as we move into lunar orbits, if we want to push out into Mars, further into the solar system, I don't think we can do that without recognizing that at some point there's a tipping. There's a tipping point in there. It's not worth sending new ones up there anymore. And maybe as launch costs come down, that line will move further and further out, but I don't know where it is right now.
Okay, thanks. Let's see. Who presented the OneWeb? Okay, good. Here's a question for OneWeb. Do all of the OneWeb satellites include the Altius? I think I read that right. Do all of the OneWeb satellites include the Altius interface? If so, what is the plan for a servicing vehicle that can utilize that interface? Does that make sense?
Yeah, absolutely. Thank you, Harley. Not all of OneWeb satellites include the magnetic docking plate. The first two batches and a portion of batch number 3, in addition to the 6 pilots, are flying a grappling fixture, which is compatible with the robotic arm. From launch number 4 onwards to the rest, to the end of the constellation, all the satellites, the generation 1 satellites will be flying and are flying the Altius magnetic docking plate. Regarding exploring in-orbit servicing missions, it's not a secret that we are working in partnership with Astroscale as part of the Sunrise ESA public partnership program to further develop these kind of technologies, in particular the magnetic plate in-orbit servicing concept. The ambition is also to do a demonstration in orbit as part of phase 3 and phase 4 of this program. So we're actively involved in this and partnering with real companies as Astroscale in the UK.
Okay, good. Hope that answers the question. Good one. Now, I intend to go all around the group here and ask the same question. What keeps you up at night? What do you worry most about? And so on. I'd like to ask Daniel that question from his perspective at the professional level at which he is working. So what keeps the European Commission, and obviously in this topic, what keeps the European Commission awake at night as a group? So when they decide to call each other at 2 a.m., what's the topic?
Hello, all together. What keeps the European Commission awake at night? I can't say, but I can speak only for me. And to be honest, just one short answer: to convince the European community related, so actors that are working in OSAM, really to try to convince them that this topic is very important. And this is something that is really, I can see around the globe, a lot of activities in the field of on-orbit servicing. And And probably the Europeans have a typical very conservative view. They are a bit more reluctant on the things. They are not that risk-taking that others are doing. And I try personally to convince this community since more than a decade now that this is a very important topic, and we have to work on all the areas that has been mentioned already by Debbie very well. There are so many things inside what we need to care about from the regulations perspective, on the system design, mission design, dedicated technologies need to be developed. We need to support all the actors, all the willing people to step in. And of course, even in Europe, there's a special situation in Europe. We have the ESA, we have the European Commission, but we have also a lot of national space programs. We need to convince all this group, a really diverse group, to work together and join forces to step really forward. And then on top of this, of course, we need to communicate on the international level with you guys from US especially, but also with the colleagues from Asia, really to guarantee interoperability, for example. That was also mentioned by Debbie, I think, before. And so we have a lot of actions here, and so this is pretty much the answer I can deliver to you on this question.
Good. Thank you. Let's see. And Bill, I think it was the question that I was asking Carl, so I apologize. And once again, crummy memory and scribbling down my notes as fast as I could, but I missed this. I was asking Carl, once again, what worries him the most? What keeps him up at night? And I saw you, this is the advantage of having all these little thumbnails. So I think you were nodding fairly vigorously at Carl's answer.
Yes.
Is that correct?
Well, we share half a brain, so that would be correct.
It's a gruesome
the other half I'm sharing with Debbie. But I think, more broadly for me, it's that the challenges that we face, for instance, the threat space or the competitive space, however you want to talk about it, in terms of adversary capability or just raw needing to be competitive from a national perspective in space, those timelines are a lot shorter than our traditional approach to developing space capabilities. A decade worth of IB&D on the ground just isn't going to cut it. And so we need, in my mind, to be more responsive. And responsive launch is one piece of that. Certainly OSAM in terms of refueling is another really great piece of that. But I think we also need to learn how to reconfigure capability on orbit, either using what we have already on orbit or adding mass like we're doing with Nomad. With Nomad, and I think that's why we're starting the program that we're starting. I think another another challenge is what Debbie talked about, is setting the norms of behavior in space. And when we had essentially unfettered access and we could define how we utilize space ourselves with very few competitors, that was a different conversation than we have right now. And I agree with Debbie. We want to make sure that is a very positive vision, which is very inclusive and enables the best use of that commons for everyone.
Good, thank you. All right, and once again, I got a number of other questions. Once again, you panelists, if you want to ask questions among yourselves or between yourselves, feel free to raise your hand or speak up. I'm sure they would be welcome.
Say, Harley, I'll throw out one thing. I agree totally with Debbie and Bill on the, how fast the adversaries are moving. Talking to somebody in the intelligence community a couple of weeks ago, and they pointed out something really interesting to me that made me sleep a little better, which is if it's hard for us, it's hard for them too.
Lord knows that's true. Okay, thank you, Carl. All right, here's a question for Debbie. I think I have this right. It goes on a little bit, but I believe I understand what he or she is talking about. So, Debbie, if you are still there, I take it that's a yes.
Yes, I'm here.
Thanks. Lots of excitement and support expressed by senior levels of USG. I think that must be U.S. government. for our commercial servicing. The U.S. government is the largest operator in space, and commercial service providers can only go so long without access to servicing some U.S. government space assets. Where are the contracts for actually performing these services? And when, how about this one? When can we expect those contracts? I'm sure.
Well,
Yeah, exactly. So Debbie, what's not what's holding back the contracts?
Yeah, that's a loaded question. And I agree with you. I want to get that moving also. That was really some of the impetus behind us, this collaboration, right? You're hearing that word over and over again. You heard it from Pam, you heard it from me a lot, and many others. But us really getting organized on one, defining what our requirements are from the United States government, right? What demand signal we want to send industry partners. And that means us really laying out our roadmap on how we want to advance things and where it makes sense for us to leverage industry going forward. But as far as just to directly answer your contract, where are the contracts? I'll speculate, right? I don't want to speak and step out on behalf of NASA, but I can speak for Debbie and what I am seeing. I think we're going to start seeing some things really, the momentum has picked up, and I envision that that's going to be the case. We are seeing so many of these technologies that are a tipping point. We're looking at what Northrop Grumman is doing, the MEV and all those other mission extension pods and those technologies and servicing and everything I'm seeing here with the industry partners that have shared just what they've shared today. We figuring out how we want to leverage that and putting us in place. I'm going to use the words, right? This can be polarizing, but for lack of better ones, right? How we leverage infrastructure as a service. And that means us figuring out what it is we are going to buy from you all with defining what we need. And we are still at the point of defining what we need. So that's basically a lot of words to tell you that the contracts aren't going to emerge tomorrow, but I think we are a lot closer in us figuring out what it is we require within government itself and moving out with that request to industry and allowing us to leverage you all and to let you innovate for us. A lot of our models that we're looking at are commercial first models. It is allowing you all to innovate and develop for us that infrastructure that we need and us to really nail down, but we've got to nail down what our requirements are. And I will emphasize too that is challenging because it is very different. Just the small team that we're working with, looking just internally in the handful of agencies right now, us finding, I talked about that nexus and that Goldilocks zone on what our requirements are, is very challenging because my partners, it's space domain awareness, it's maneuvering without regret. For us, it's servicing, it's being able to do precision assembly, it's large aperture telescope assembly in space, right? There's we have different mission and objectives. So again, finding that common ground, moving out as a government and sending that demand signal to industry with that will emerge with the contracts and the different models in which we want to leverage you all. So in a nutshell, I don't have a clean answer for you, but I can tell you that we are moving forward. And we are seeing much more momentum behind this than we have.
Well, God, I assume that you would welcome any substantive help from the folks here on the panel and moving it forward.
Yes, the big word here, advocacy. I mean, collaboration and advocacy. I think we are, a lot of what you're seeing now really bubbled up from the grassroots level. When I say what you're seeing, the internal government aspects, but now it's risen up to the federal level, and that's very positive, where we've gotten engagement with OSTP and Space Council, but we also need advocacy from this broader community. So we are, it sounds so cliche-ish, but we all really have to advance these technologies together. We're not going to do it alone in government. Industry is not going to do it alone. And that's figuring out what that stepping stone roadmap is, which is what we're really trying to tackle to advance and move this forward. And that's, heavy involvement from our international partners also.
Good. Thank you. Let's see. I'm not sure who is the following question. I think is a good one. It was an area that decades ago I was involved in, so therefore I think it's a terrific question. I don't know which of the panelists best answer this. So wave your hand if you'd like to answer it. And the person asked this for all the panels. Are there challenges ahead for OSAM requiring the allocation, agreeable and plausible, requiring the allocation and assignment of specific radio frequencies, especially in competition with other activities such as mega constellations and so on? Assignment of radio frequencies, a huge topic that probably does not get all the attention that it should as we develop architectures. Anybody want to take? Carl.
Yeah, so I'm not an RF expert, so take this with a grain of salt. But some of the questions that I've started asking with respect to OSAM is, what can we do in terms of frequency allocations, in terms of short range communication between, say, servicers and clients? Can we utilize spectrum that we normally don't utilize in space? Typically space frequencies are allocated based on their ability to function between spacecraft and ground connections. And spacecraft to spacecraft connections are not as common. And so can we start utilizing essentially, the equivalent of Bluetooth in space for servicing? So I think we need to rethink the way we are allocating frequencies. And we also need to rethink how that fits in with things like laser comm. I mean, crosstalk in systems is going to be a problem. But I think we could actually be a lot more flexible than our current system allows. We just have to be a little more imaginative.
Sounds fine. Actually, and Danielle, this, once again, from your perspective, is allocation of radio frequencies, which is a serious strategic level issue. From your perspective, do you see challenges with the massive development of capabilities in space, particularly the types of things we're talking about here? Do you see challenges in radio spectrum allocation?
Well, also before giving an answer here, which I cannot, obviously, because I'm not the expert in this field. So, and as you might know, the commission is very big, it's not that small, and we have a lot of experts also working in this field. So as far as we know from our studies, the small studies that we did in the context of on-orbit servicing, this was not yet, let's say, raised as a big issue. However, I have already heard that there might, let's say, especially in the context of our per aspera activity and the European Operation Framework, where they work on guidelines for on-orbit servicing, also, by the way, closely together with the CONFERS. And I have heard that there might occur some issues in the future, but from the perspective of the Commission, this has not been analyzed in detail what regards on-orbit servicing. So from this perspective, I cannot contribute to this.
Thank you. I suspect there will be. I mean, again, frequency allocation is a biggie. So we've got just a couple of minutes left, and this is a good one. It goes mainly to Debbie, but I think there will be other folks who will want to weigh in. So Debbie, as briefly as you can, and then anybody else who wants to weigh in answering this question, shoot your hand up. Okay, so Debbie, when OSAM started, parentheses, as Restore, there wasn't an industry established for satellite servicing and in-space manufacturing. So it made sense for NASA to absorb the risk of developing technology capabilities. We saw great capabilities this morning from industry in those areas. So what's the next technology gap that NASA wants to fill in satellite servicing, debris removal, and other areas we're talking about? So where's the next gap that needs to be filled, Debbie?
Yeah, I almost need a whole session to talk that one. So.
Yes, Debbie, you bumped your mute button. And Brian's come in. Debbie, are you logging in there? Huh. Strange. So tell you what, until we do want to hear from Debbie if she gets in. Carl, what would your thoughts be about the next big technology?
For me, I think the key is we're starting to move down the road with stuff that Bill is doing at DARPA on the manufacturing. NASA has been working on assembly. The next big thing is combining those two things together, and what is the killer application? I think servicing and refueling makes perfect sense. From a NASA perspective, big telescopes, we can go assemble those. But what is the commercial thing that requires assembly and manufacturing? And that's not really a technology per se, but it is a problem.
Right. So Daniel, I think you had your hand up on that question, didn't you?
Yeah, right. I don't know if Debbie wants to go before, because the question was asked to her, but from just to give a short message from our side here in Europe, from European perspective, we think we need to work on standard interconnectors, for conducting an efficient servicing. So when we talk about refueling and satellite upgrade, for example, this could be a really promising field. So to enhance satellite platform in orbit with new functionality, to enable to unlock new mission objectives, but also then to allow an efficient assembly in space, so that when we have defined the let's say a kind of standard on these interconnectors, where you can plug and play like USB in space, where you can plug and play functionalities like modules. I call it Lego in space. This is a thing that we are working on since decades now. And I think with this, let's say, core item, we can enable a lot of more business opportunities. And this goes hand in hand, for example, perfectly with in-space logistics. Taking the warehouse principle, for example, you have a port, you transport, you launch a packet of, let's say, I call it DHL packets. You call them the modules to that platform, where you can, with robotics or highly automated assembled stuff, you can create a mass customization in space. So you can create a manifold ecosystem based on such a simple connector. You have a perfect example in terrestrial sectors like IT. Apple, for example, always they create with a small thing a whole ecosystem. And this is missing in space. And this is the next big thing we need there. And so this is also, by the way, the core of our activity here, what we call future space ecosystem.
Right.
Okay.
Thank you. I think we have to wrap this up. Brian, you're gonna share your views of how the last 4 hours have gone. So, Brian, the floor is yours.
Well, thank you for that, Harley, and thank you to all the all the presenters that have come so far today. We can go ahead and drop the slides. I'm just going to go ahead and speak for the last few minutes here. So we wanted to close out today by talking about what's been happening with standards work on the behalf of CONFERS. As Pam mentioned in her keynote, and as have come up multiple times throughout the today's sessions, when DARPA first laid the foundation for CONFERS back in 2017, it was based on the idea that creating standards was key to helping foster a thriving and sustainable commercial satellite servicing industry. I think it's interesting to compare some of the topics we talked about so far today and what's missing from space that we take for granted in other successful industries, such as automobiles. Think about how we design and use cars. We have standards for safety equipment like lights and mirrors, and interoperability equipment like tow hitches and refueling ports. All of those standards help make the automobile industry both safer and more attractive to customers, while also fostering the development of the huge market of suppliers and service providers, and third-party add-ons. We don't have any of that yet for satellites, in large part because we don't have the standards. Thus, since our founding, the consortium has dedicated a significant amount of our energy to convening discussions among our members and government subject matter experts on how we can work towards developing standards that can do all the same things for the commercial satellite servicing industry that have been done for the automotive industry, or what was just mentioned, the smartphone industry. I'd say that it hasn't been easy to do this because we're talking about, getting together companies that are competitors in different stages of development to try and, talk and hammer out some of these details. But we have made a lot of progress, and I want to take a few minutes to recap what we've done and also where we're headed. The first step that CONFERS took, as mentioned by Joe Anderson in his initial talk this morning, was to develop our guiding principles that laid out the fundamentals of how we think commercial servicing should be done. Consensual operations, compliance, relevant laws and regulations, and conducting them responsibly. Those served as the foundation for our next product, which were the CONFERS recommended design and operational practices. These practices gave more detail on specific actions that companies should be taking during the design, development, and operation of satellite servicing missions to help ensure safety and reliability. At the moment, we are working with our members to finalize an update to both the principles and the practices that we plan to publish on our website within the next month. As a bit of a spoiler alert, I can say there's not going to be a huge amount of change because I think that reflects the amount of work we did originally to try and get them right the first time out. But we have made some tweaks that reflect some of the lessons learned from these missions you heard about earlier today that the members and these companies are finally getting to do on orbit. In addition to the CONFERS principles and practices, we've also been working on developing actual standards. The first and most advanced standard is ISO standard 24330. The International Organization for Standards, ISO, is the world's premier international standards organization. It's used, they are using the CONFERS principles and practices as the baseline for what's going to be the world's first satellite servicing standard. We expect it to be, it's currently in progress. There's a group of multiple international or multiple governments that are and international experts from industry and governments that are all sort of working on refining that. It's gone through a couple of votes. We expect to be finalized either by the end of this year or in early 22. And we're really excited to see that finally come out. Earlier this year, CONFERS also initiated development of our second standard. And this is on spacecraft fiducials to support rendezvous and proximity operations. I don't know if you noticed earlier in the video that Katai showed, they had fiducials on those little parts that their robot was assembling. But fiducials are visual markings that help satellite servicing spacecraft or robots detect, identify, track, orient, and approach another object or work with an object in a relatively safe manner. This standard is under work within the AIAA. They have created an international standards group back in March that includes both CONFERS members and other technical members who are talking through the initial kind of details of what a spacecraft fiducial standard might look like. Finally, I'm happy to announce that we've recently started work within CONFERS on a third standard. This time it's focused on refueling interfaces. A standardized refueling interface is something that many satellite manufacturers and potential customers have said they would like to see in order to help create a market for in-space refueling. And we heard earlier today about how that is probably the next big service or part of satellite servicing that we can make feasible. So to that end, within CONFERS, we've convened a group of experts from our members who are starting to put together what the framework or the outline for such a standard might be. And we hope to approach a standards development organization by early next year to begin working on it. So as I mentioned at the very beginning, all of this has begun as a result of the foresight of DARPA, and particularly Pam Melroy, who was there at the time, who had the vision for the consortium and have so far provided the initial funding to help support our activities. And we thank Pam and DARPA and the rest of the people who are involved for for that foresight and for their vision. So we're going to be wrapping up today's activities. Before we conclude for today, I'd like to once again thank you to our sponsors who helped make this event possible. We have Astroscale, Space Logistics, SpaceAble, Voyager Space Holdings, Space Infrastructure Foundation, Orbit Fab, Lockheed Martin, MDA, aerospace, and space news. Please join us all again tomorrow for our second day of content, which is going to be just as good, if not better, than the first. We begin at 0900 Eastern Time with a keynote address from Rolf Denzing, who's the Director of Operations from the European Space Agency, head of the European Space Operations Center, who is going to talk about their role and their interest in satellite servicing. So with that, thank you all for joining us today, and we look forward to seeing you all tomorrow.